Hello everyone and welcome to Cisco ManageEngine joint webinar titled QoS Design and Validation for Enterprise Networks. We are glad to introduce to you our guest and main presenter, Ken Briley, Technical Lead at Cisco Systems. During today's webinar, you'll get to know more about designing QoS policies for your enterprise network and monitoring QoS policy performance. So during today's webinar, your phone lines will remain muted, and you can type in your questions using the option available in your GoToWebinar window. We'll also try to have a question and answer session at the end of the webinar. So once again, welcome to the webinar, QoS Design and Validation for Enterprise Networks. So before we start, very briefly on what ManageEngine is for those who are new to us. So ManageEngine offers simple, easy to use IT management products at a price that every business type can afford. So we have products that can cater both to SMBs as well as large enterprises. The products we have for IT requirements, they range from network and applications management to asset management, help desk, syslog analysis, Active Directory management, password management, vulnerability assessment, all these, almost anything that an organization needs for its IT monitoring management. So the webinar agenda is, we'll start off with an introduction to QoS where we've discussed what is QoS and the need for quality of service in your networks. And then Ken Briley, Technical Lead, would take over and explain about QoS, designing QoS for your enterprise networks, validation or monitoring cost policies, and finally we'll show you some cost reports in ManageEngine NetFlow Analyzer. At the end of which, we'll go to the question and answer session where you can type in your questions and Ken would try to answer them for you. So what is QoS? QoS, what you need this is because you have a variety of traffic going through your network. You have VoIP, you have mail traffic, you have peer-to-peer applications, you have HTTP traffic, all these traffic traveling through your network, and your preference would be for a certain type of traffic. That is, maybe business critical traffic is more important, or maybe VoIP traffic is much more important over the other traffic. So a method to optimize and prioritize traffic on the network based on your key objectives. So that is what QoS is all about. So this way, using QoS, you can ensure delivery of business critical applications or delay sensitive applications like VoIP and video calls at all times. So what is the need for quality of service or QoS? So one reason is converged networks. So today you have VoIP or video or data traffic, all of these different data traffic types, different traffic types going over the same IP network. Now when this happens, all this traffic comes into the best effort category. That is, they have an equal chance of being delivered or dropped at the destination. So sometimes data traffic can get dropped, voice can get dropped, or even video traffic can get dropped. Now what happens is you are not sure which application is going to be delivered, or you're not sure which conversation is going to be delivered or which conversation is going to be dropped. So this is where QoS can help you. Priority treatment for your applications, for whatever application you have importance for, or whatever applications you need to be delivered. So have business critical applications, generally they would have to fight out with the other applications which normally should have been under a lesser priority, maybe scavenger class or just bulk data. So QoS is going to help you segregate your traffic for priority treatment. That is one reason why you need QoS in converged networks. Something else is congestion points. So today IP networks are bound to have congestion points. The reason being something like what you see on the screen here. Link aggregation, which is like which ends up having a higher input speed interfaces going through an output, single output interface with lower speed. And maybe a LAN to WAN connection. That is, LAN interfaces you would typically have high speed interfaces, and WAN interfaces or WAN interfaces are not as do not have the same speed as your LAN interface. So what happens is this speed mismatch causes congestion points. So these are scenarios where you can get see congestion points and traffic drop can happen. So have control. You can have control on what data is dropped, when, where and how it is dropped, that is what QoS is going to help you with. And next part is delay-sensitive application delivery. So you have increase in IP-based voice and video communications. Almost every business is shifting to voice and video because it's much more cost-effective than rather than having people at their destinations. And this IP, this media traffic is actually sensitive to delay and packet loss. You see a delay in packet delivery, or if there is a packet loss, what you would have is a very poor quality voice call or a very poor quality video call. So ensure that your delay sensitive applications get the priority when needed. That is what QoS is going to help you with. That's something else QoS is going to help you with. Now, something else that might not have been widely recognized or used is DOS attacks. So you can stop DOS attacks to an extent with quality of service. So what is DOS attack? It consumes resources to deny legitimate service requests. So resource regulation is an important factor for controlling or for stopping DOS attacks, and QoS is what you can use here. So you can put non-business applications in a scavenger clause which prevents resource utilization in case there is a DOS attack. Or even the Cisco's Catalyst 6500 series devices, they support something called as micro-flow policing, where you can polish traffic for each port or VLAN on a per-flow basis. So you can regulate your resources, you can control how much of the resources is being used by each IP, and thereby you can deny that DOS attack, which might actually be trying to consume all your resources and thereby denying legitimate traffic service or service request. So at this point, we'll move on to quality of service in detail. We'll have Cisco taking over the presentation. So over to Ken now. Ken, thank you so much for joining us today, and we are ready to hear on quality of service presentation.
Absolutely. Okay, let me find the screen. All right, can you guys see this?
Yep.
All right, so let me briefly introduce myself. So my name is Ken Briley. I've worked at Cisco Systems for about 10 years now. 6 of those years have been related some way, shape, form to quality of service. Started out in TAC, moved to the 3750 business unit, and then to the 4500 business unit as a TME, and then focused for a few years on end-to-end deployments for quality of service and in advanced services. And now I'm in OSTG, which is a technology group that owns iOS XR, iOS XE, standard iOS, all of the operating systems from the PI side for Cisco. And so I'm the QoS TME, so I have a pretty good understanding of quality of service parameters and all the information associated with that on most of our platforms. So please feel free to send in a question over onto the right side, and we'll try to answer those as much as we can throughout or towards the end of the presentation, our Q&A session. If we're not able to answer those again, we'll send those out in email. So the agenda today is really going to focus in on something that Don just covered, which is why QoS, why are we actually even talking about quality of service today? What are some of the business requirements leading into quality of service and the evolving business requirements that may require that you come back and revisit the policies that you actually already have in your network today? And then some design considerations from the classification, marking, policing, and queuing perspectives of quality of service, the main foundational components. And we'll dive in from a fairly high level about things that you should look at even in your current policies that you may want to modify based on recent changes to RFCs and things of that nature. Application control is a section where we'll actually look at a few CLI examples of quality of service. We won't go too deep because we do only have about an hour to do the presentation. But from the QoS standpoint, the campus CLI and the WAN CLI, we'll dive in, give some examples, and talk about NBAR classification properties, policing, and the overall queuing mechanisms that we have. And then finally, We'll wrap up by talking about visibility and monitoring of QoS and link that into the ManageEngine application and essentially tie it together to show you how the GUI really helps you reevaluate quality of service overall. It really helps you understand the applications within a network, and it helps you overall deploy quality of service based on the simple fact that you understand what's going on inside the network. All right, so let's start by business and technical drivers. So the first one is the explosion of video applications. I know myself, I'm constantly doing video calls here at Cisco, either via telepresence or at my desk phone at home. I actually have a video phone at home as well, and we all use video-based applications. So the business requirements are now changing, leading more towards the video application side, quite simply because we're all used to seeing each other face-to-face for either team meetings or what have you. On top of that, the impact of HD, the new bandwidth requirements for it, which we'll see in a bit, are outstanding. If you move from a typical voice system in your network that's just standard IP telephony directly into voice and video through your IP phones, you're going to see a huge impact on overall bandwidth consumption, quite simply just based on either 720 or 1080p video calls. This is definitely something that's a business driver these days to modify or change your QoS policies that you've had from yesteryear. The last thing really is a blurring of voice, video, and data application boundaries. Applications are becoming much more complex. And if we take a simple example of WebEx, we notice that WebEx itself it's not a single component. It has multiple components in the underlying infrastructure. So you need to classify those individual components if they're important to your business. RSC 4594 and 2597 have both been updated over the last few years. And so recently some modifications have been made. So you may want to reevaluate some of these RFCs. And then lastly, from the Cisco side, there are a lot of new platforms and technologies that have come out over the last couple of years. A few to note are the 4500 with SOUP 6 and SOUP 7, and also the SOUP 2T on the 6500. Those platforms are quite different, and the supervisors are quite different from a QoS standpoint than previous supervisors ever have been, meaning that they actually support something we call MQC or modular QoS CLI construct on the campus-based switches. So this is something that you'll want to take a look at some of the new features and functionality of the devices, and reevaluate those as you look at the technical drivers within your network. Now, when I mentioned telepresence, essentially internal to Cisco, we have to fight over the telepresence rooms because they're honestly quite often used most of the time. So they're rolling out more and more telepresence rooms internal to Cisco. We also have video phones at our desks, and also via CVO, our at-home access, we have video phones there as well. And so video in general is just becoming more prevalent. And you can see this by a visual networking index that we put out, once every so often, and generally we see this specifically at Cisco Live, and that's where we usually illustrate this. And it tells us just the range of changes that we're going to look at from a QoS standpoint if we focus on QoS. Number one, we see the IP traffic is going to quadruple by 2014, and the other thing to really point out is that the sum of all forms of video, meaning the things that I've been talking about, telepresence, voice and video integration, will actually exceed 91% of all consumer traffic by 2014. So this leads us down the path of we definitely have a business requirement for video. We need to make sure that we provision for that within our enterprise and verify that QoS is capable of handling the new video applications that are going to be arriving. So when I talked about video, we were also talking about the impact from the bandwidth perspective. And if you look at different calls, if you look at 480p codec versus 720p versus a 1080p, you're really doubling from the perspective of each of those iterations the bandwidth requirements for these applications. So if you imagine rolling out voice over IP phones and then 2 or 3 years later coming along with video phones and applying those into your network, just from the video perspective, the bandwidth itself is something that you would need to allocate bandwidth for internal to your QoS policies. So video is a huge business requirement. I know we've mentioned it multiple times here, but from a pure bandwidth perspective, video is a main driver for updating your QoS policies moving forward. And again, if you look at your voice packets versus video, not just from an overall bandwidth perspective, but from a burstiness and a buffering perspective, video itself in today's time is so much more complex than a typical voice call. So we need to take into consideration the overall bandwidth requirements and buffering capabilities for the video if we're deciding to integrate that into our network. The other piece is application trending from voice, video, and data applications is really going from the typical web and email messages we all know from 20 years ago to the converged, avid sort of voice, video, and data individual applications where we could classify a voice call, we could classify a data application with a single ACL, to a mishmash of converged collaborative applications. I'm not sure how to shrink this, sorry. Which one maybe example that we took previously was WebEx. WebEx has a voice component, a video component, and data components internal to it. It doesn't have a single port number that we can match. We have overlapping port numbers between video and voice applications themselves. And so it's very difficult to pull individual applications that are collaborative out of a single class, like a best effort queue, when we have overlapping port numbers and things of that nature. So we need to think along the lines of a little bit more DPI from that perspective. DPI meaning deep packet inspection, which is NBAR and NBAR 2, which we'll talk about in a second. Another thing to consider is that we talked about the RFCs changing over time. Well, RFC 4594 has been updated a little bit. 2597 has also been updated a little bit. So you may want to review those. But again, these are informational-based RFCs. So when we look at them, we see the applications on the left and per hop behavior. It gives us a little bit of information on whether we should be queuing or dropping this class. And it allows us to understand how we should really group applications based on technical requirements. Now, with that said, from the Cisco perspective, CS3 and CS5 are a little bit different than this specific RFC. CS3 at Cisco and for Cisco equipment is related to call signaling. You'll notice that because all of our call managers are set up for CS3 for call signaling. The reason that we've deviated a bit from the RFC here is quite simply because call signaling doesn't really have the same requirements as voice bearer traffic does, so we're able to remove it from the priority queue. And so we've done that by marking it as CS3 as opposed to CS5. The other reason behind this is quite simply that CS5 does have the requirements for the priority queue, and we want to keep the priority queue as clean as possible so that it is based on priority traffic and not a bunch of other applications. The next thing to consider is as your network evolves, so will the number of classes within your QoS model. So you'll start out with a 4-class model most likely. If you integrate voice into your network, you may have real-time applications, and then you'll have to control the signaling with those real-time applications in a separate queue, and that queue may also have your network control and just overall control within it. The critical data will be a separate data queue where you put Citrix or SAP applications, or just applications that you feel that are important to your business. Then again, your best effort queue is going to have all of the traffic in there that hasn't been classified, and this is an extremely important class that we're talking about here. The best effort class is essentially everything that you haven't classified, and so quite a few applications, even fairly important ones, will fall here, so we need to make sure that we take a look at that class as well. Most customers evolve from a 4 to a 6 to an 8 class model after they integrate quite a bit of video into their network. But unless you really have a requirement to move to an 8 class model, it's generally not recommended. We want to keep things from a QoS perspective as easy as possible. And so when customers talk about moving directly to a 12-class model, we hope that they take into consideration the management that it requires to look at all of the classification criteria, manage all of those ACLs associated with it, and focus in on the management of all of those individual classes. But if you actually do have the applications available to fit into these classes and the bandwidth for these specific classes is necessary to be tightened up, then absolutely go for a 12-class model. But again, just something to note as far as considerations go. Now, with that said, that was a fairly high-level overview of the design considerations from the overall perspective of quality of service. And now we're going to get into the details, and we'll start with classification and marking. So the main part of quality of service and the reason that quality of service actually works is the ability to classify individual traffic types and specific applications. And the reason this slide is here is to really demonstrate how it should be done, which is we want to push this to the ASICs as much as possible. If we push classification and marking into the hardware, which is generally there at the access edge, everything is done in hardware, and it allows us to offload the CPUs from the WAN side of the house. Now, today with ISR G2 and ASR 1K and the larger CPUs that have come along, it's not a huge requirement, but every bit of CPU helps on these platforms, specifically when they're doing routing and intensive applications and they're doing DPI, which is really what we want them to be doing there at the WAN. At the access edge, again, focus on putting as much classification and marking into the hardware as possible. Where it should be done is quite simple. We want to establish what we classify as a trust boundary. As traffic comes into the network, just like someone comes in your front door of your home, you want to verify who that is. When traffic comes into the network, we verify it by classification, we mark it there at the access edge, and then we allow it free reign all the way up into the distribution in the core. It's already been marked, so we can queue the traffic, but we trust the markings, per se, from a DSCP perspective as we move to the distribution in the core into the network. The other piece of this is that we may want, at the WAN edge, the main congestion point of the network, to dive deeper into the packet. So we provide DPI on the routed platforms, which is generally ISR, ASR. When we want to dive in there, we're going to use something called NBAR. Now, this is the DPI engine that we have here at Cisco. What NBAR does is it provides us with the capability to dig extremely deep into the packet and provide more information than you normally could with an ACL. We had NBAR, and we started out with NBAR quite a few years ago. We've revamped the engine as of late over the last year, and it's already incorporated. NBAR 2 is in ISR and the ASR, and what it actually does for us is provides us with over 1,200 signatures. We've incorporated the old NBAR signatures and the new NBAR signatures, and it's provided a bunch of innovation by way of allowing us to look at IPv6 as well as IPv4 packets and targeting specific applications within those packets. NBAR also works on encrypted packets as well, so things like Skype, it does extremely accurate review with NBAR 2 and the new heuristics for matching Skype voice and video and all of the data pieces of it. So it's a very good tool to use to essentially tie together the standard classification with DSCP and then deeper packet inspection, which we generally need in the WAN. Now, though NBAR is an engine and it has the DPI engine there, we basically need to use the engine, and there are three options to really do that. The first one is protocol discovery, which you can enable on an ISR and ASR, and what it does is it does application discovery for you on the platform. It will essentially look at all the traffic running through the router, categorize the traffic based on the application information associated with NBAR and NBAR 2, and provide you with extreme details that can actually be viewed in the CLI or with ManageEngine via a MIB. Okay, so this information can also be collected. NBAR information can be collected and tied into flexible NetFlow. So the standard NetFlow 5-tuple, the information there, can be coupled directly with the NBAR information and then exported again via NetFlow to ManageEngine so that you can look at the overall list of applications, the type of applications, and all the details based on packets, bytes, and things of that nature associated with those applications. Now, this is going to provide us, from the standpoint of classification and marking, the capability to classify the traffic, but also when we look at the ManageEngine profiles and things of that nature, what we'll see is how traffic and how applications are behaving on the network today. And so it allows us to revamp our QoS policies and get into some detail associated with that. The last one is easily to match the protocol. And this is the one that generally you'll see in the presentation here and the one that you'll see out there in the real world, where people use match protocol to match Citrix or Skype or to match individual HTTP flows in order to either pull them out of the best effort queue or to throw them into scavenger class like BitTorrent, things of that nature that may not be business critical for their specific environment. Now, NBAR 2 actually provides a way to simplify policies, and what it can actually, what it can do is specify an attribute category, for instance, in this case, email. So what it does is it looks at all email applications within the NBAR construct, which is Outlook, Gmail, Hotmail, all email-based applications, and ties them all together in one specific classification criteria. So you no longer have to specify multiple applications one after the other as a classification criteria on the WAN edge. You can just specify one based on the category. Now here's a quick list for your reference, and we'll send the slides out if Don already hasn't. But basically the categories are listed on the left, subcategories and the individual applications are there. And truthfully, it makes sense because with NBAR 2 we have over 1,200 individual application signatures. So if we were just to list those out, it'd be quite an extensive list for you to have to go through in the CLI. You can focus in on the categories and the subcategories. And the example here is Skype. Skype group actually has over 13 individual signatures in it. So if you wanted to pull Skype out of the best effort queue, put it in scavenger or even put it in business class, you could actually do that with an individual class criteria. Now how it should be marked? Traffic, the way traffic should be marked is based on your opinion within your network. RFC 4594 is a reference only, so you can mark traffic however you want, but if you stick to RFC 4594, it's more than likely that if you merge your company with another company, it'll be easier to do so via the QoS policies. It'll also be easier to take the policy that you have on that WAN edge and place all of those markings directly into the service provider, given that the service providers as of today are really leaning towards a more RFC 4594 based solution. And so you'll see that they provide AF3, AF2 classes with different thresholds and things of that nature. So it's much easier to fold all of the traffic into either a merged company or to a service provider when you keep track of it with a standards based like RFC 4594. Now, Don mentioned policing, and basically the recommendation here for policing is twofold. You can get in trouble when you configure a policer when you have to revisit that policer quite often. So the idea here is to, when you apply a policer to any specific class within the QoS construct, that specific class should probably have deterministic data within it. So if you put a policer on the voice class, you recognize that there's a codec associated with it. So your best guess is that since there's a G711 codec coming into this specific port, I can classify that traffic and police it to 128K, knowing that I should full well never hit the policer. And that's the idea. I shouldn't ever have to revisit that policer and modify the policer to 384 or whatever unless I modify the codec associated with the phone or if I swap out the phone. So it's less frequently than if you were to attach that same policer to a data class. Now that leads us into scavenger class QoS, which is a very good idea for tying down the distributed DOS attacks and things like that Don was talking about. But when we use scavenger class QoS, you apply a policer, traffic over and above the CIR reference internal to the policer will actually be remarked or marked down to a scavenger class value of CS1, Once that value traverses the network, as you see here, any point that we queue within the network, that CS1 traffic will be given its own class and will be allocated a very minimal amount of bandwidth so that that CS1 traffic, that excess traffic, will be dropped more aggressively than the other traffic. Now, the only downside of this that we see is that you will have to manage that policer, because if you were to upgrade Citrix or a SAP or individual applications within your network that are tied to that scavenger class policer, you may end up having to revisit all the policers across your network at that point. Now, again, it's a very good safety valve, but at the same time, recognize that you need to verify that you're not hitting this policer, verify the drops, and you can do that with a tool like ManageEngine. Now, from the design principles, where should it actually be done? Where should we actually do queuing? Queuing is something that needs to be done to control the entire network from end to end. If we don't have or we don't provide queuing behavior, we can't enforce any sort of behavior on the traffic associated with these interfaces. So if we were to decide not to do queuing at all on the access edge or the distribution, it's free reign for all the traffic that we marked. It doesn't really matter. You could drop voice, you could drop video. The burstiness within the LAN could possibly drop anything. So we recommend generally that you, when you configure QoS, you do it from end to end. And some basic guidelines are listed here on the left. They've been around for quite some time. 25% for the best effort queue is basically based on, is loosely based on the fact that most of the traffic within your network today, you may have 3,000 plus applications. Most of those applications won't be classified. And some of those applications that aren't classified may be pretty important. So allocating an overall bandwidth to that specific class is extremely important. Don't forget about that. Priority queue, 33% was the value given based on testing and just general logic. If you specify 33% bandwidth to a priority queue, 1 in 3 packets going out the interface is going to be associated with that priority queue. If you go higher than that, you're essentially saying that more traffic is really priority than the other traffic. So if we go up to 60 or 70% priority and the priority queue is a strict priority, 60% of the time the scheduler on that platform is going to be spending on the priority queue. So there's a threshold there that you may cross where you start impacting standard data traffic because the priority queue is so overfull. And the best practice behind this is we try to keep the priority queue as clean as possible because it's for really low latency and intolerant applications. So there's the recommendation for that. Scavenger class is around 5% because we've incorporated bulk and scavenger into one queue in this instance. And then the last thing is congestion avoidance really shouldn't be used on UDP-based flows, meaning weighted red shouldn't be because it really doesn't affect them. TCP-based flows really work well with congestion avoidance algorithms like weighted red because they do use a TCP algorithm and back off. And so that's generally where we use that. One big question about campus-based QoS is people generally ask, why even do it? WAN-based QoS is good enough because that's our congestion point. We don't have any congestion at all in the core distribution and access. But there are a few reasons that we need to cover and consider the deployment of QoS within the campus. The first one being we want to offload the CPU. We've already said that that's not as big of a deal as it has been previously, but offloading the CPU even 1% or 2% is extremely important when you're using DPI. We want to make sure that the boxes are using DPI to the best of their ability. The second thing is at the access edge we draw the trust boundary and trust all the traffic into the distribution and core. And the third thing is because of the burstiness of video these days, traffic as it comes into the access may go up to the distribution and back into the access or may go out to the WAN, and you have a typical ratio of 20:1 of oversubscription between the access and the distribution. And a huge burst via telepresence or other video applications could easily cause your application to basically be dropped. And if you don't configure queuing, it could be your priority queue traffic that would actually get dropped. So your voice and your video traffic would get dropped over the distribution just based on a simple burst. So as a summary, we're basically talking about creating a trust boundary at the access edge. From there, we queue as much as possible at every single point in the network so we have control over the application. And then we can use features like user-based rate limiting on the 6K or sorry, on the 4K or microflow policing on the 6K to control traffic in a more granular fashion. So from a high-level design perspective, we've covered all of our bases: classification, marking, policing. We've talked a little bit about NBAR. Now let's look at an actual policy from the WAN and the campus side and dive in a bit. So from the campus side, if we talk about application control via quality of service, this is basically what it looks like. Here's a standard MQC policy. At the very bottom, we have an interface range command that basically is going to apply all of the QoS policies to this range of ports. We've configured the policies above on the VLAN. So this is a 4500 with running SOUP 6 or SOUP 7, doing MQC, allowing us to do per VLAN quality of service. So we have VLAN 10, which is our access VLAN or the data VLAN on these ports. The voice VLAN is 110, and we're applying these individual policies on those specific VLANs on that interface. Now the VLAN-based policy is quite simple. It's just marking EF, having a policer set to a specific rate of 128K. So this is a G711 call or G711 phone behind the voice VLAN. And then the data VLAN is just marking transactional traffic based on a simple ACL. Now the queuing side is a bit different. Since we've limited the traffic for the priority queue based traffic, the voice and the video on the LAN side, we don't need to specify policers on the uplink side. So from the queuing perspective, we already have the value. We understand 128K per port, multiply that times the number of ports, so we know how much traffic is going to go into the priority queue. So we don't really need to bound the priority queue on the uplink, though you could for additional safety. Then what we do is we allocate bandwidth with the bandwidth remaining % command to all of the other classes associated, and we allocate the bandwidth based on the requirements of the application. Now on the WAN, what we can do is something a little bit more granular with NBAR 2, and there's 3 ways, as we talked about, to apply it. You can do it based on protocol, you can do it based on category, and the third way is to do discovery. Now, we don't really have a slide on discovery, but it basically learns all the traffic and all the applications. In this example, the WAN-based policy was based on business applications focused on browsing. So the business requirements from the customer would be something like, we have a lot of browser traffic, but internal to that browser traffic, there's a specific server, a specific URL that we find business critical, and we want to protect that set of URLs. So what you could do is use an application like ManageEngine to take a look at the HTTP flows, figure out which ones are most used, which ones are business critical, come back to the WAN policy and specify, for instance, under my network policy, you have a class of browsing. You allocate a certain amount of bandwidth for that group, because if you notice, class browsing calls out a category for browsing. So every type of browsing traffic going through that box is tied to that. Excuse me. From there, we call out a service policy for the internal browsing, which ties a certain amount of bandwidth via that second policy, the internal browsing policy, 60% of the bandwidth to that specific URL. So what we've done is if you look at the bottom right, we've allocated a certain amount of bandwidth for the interface, tied that down to a certain amount of traffic for browsing, and a subset of that browsing is very important to us. So we've essentially catered to that specific traffic. Now with that said, what you can do is you can look at these individual policies, either campus-based policies or WAN-based policies, and you can use ManageEngine to do this. So you pipe out the NetFlow information, and you can look at the class-based QoS MIB as well to look at what the policy looks like or what the network looks like pre-policy. So you can see your applications running in the top left, and on the right, based on how that policy is affecting the traffic, we can take a look and see, is best effort traffic getting dropped during congestion? How much of the overall traffic is actually getting through? So we can use ManageEngine as our NetFlow collector to essentially go in there and analyze the traffic in such a way that it may help us to improve our QoS policies in the future. Now, the last thing I want to talk about in this section is campus and WAN alignment via MQC. So one thing internal to Cisco with quality of service has always been that we expose the ASICs because we want customers to get as much out of the ASIC as possible based on feature sets and configuration capabilities. Now, we've moved to the MQC construct on the Catalyst 4500 with the new SOUP 6 and SOUP 7 platform, new supervisors, and with the SOUP 2T on the 6500. And we're going to progress that way so that the ASR, ISR, 4K, 6K, as well as the next generation platforms that come out will be focused on MQC. This construct is not just focused on quality of service, but it's called C3PL internally, which is Cisco Common Provisioning Language. Basically, it's Cisco's common provisioning language that allows us to classify and create policy maps, class maps in a structured fashion. So we can do this across not only the 4K and the 6K today in the SOUP 2T, but also the ASR, ISR, and we're extending C3PL to things like performance monitoring, iOS firewall, and e-edge. So this same construct is used throughout all of these features. So the big thing to notice here is that QoS number one is always on. There's not going to be any MLS commands in the future. The trust paradigm will be null and void because with a router and MQC-based configurations, you don't really have trust. The packets come in without modification. Everything is explicit. So we need to have access edge policies to really enforce that trust boundary at the access edge. So a single unified provisioning language allows us to move policies between platforms as well fairly simply. And that makes easier an easier life for all of us who have to configure QoS because we don't need to learn as much about the internal ASICs and all the internal details as we did before. Now the last section, monitoring QoS, we'll dive into NBAR, flexible NetFlow, some of the details there. So hopefully we have a fairly good base of some of the design requirements for quality of service. Some of the things that we need to take into consideration being HD video and things of that nature. And now we can basically look at the policies that we've created, and from those basic policies, we can monitor them and then modify them if we have to. So when it comes to monitoring, the depth and the scope of monitoring really depends on the goal. The end goal could possibly be, looking at link utilizations and packet drops. It could be application profiling, trying to figure out what's in the network. It could just be troubleshooting, for instance. So we use NetFlow and to identify mismarked applications. It generally gives us a 5-tuple, provides us some pretty good information, and allows us to send it out to collectors to provide a nice GUI view of the overall applications in the network. We have class-based QoS MIB and port MIBs that give us statistics based on QoS statistics on the platforms that can also be transported out to individual collector. And then NBAR protocol discovery coupled with flexible NetFlow is a very interesting tool that can allow us to troubleshoot and monitor the network as traffic flows through. So the idea here is really collect as much information as we can from the network, tailored down to what our goal is, and use that information, pipe it to ManageEngine or the typical NetFlow collector, and get sorted details on the applications within the network so that we can provide the applications with what they need. The first one that we'll talk about is the Cisco class-based QoS MIB. This is basically the show policy map interface command spread across the overall MIB itself, so you can take this information from the show policy map interface and pipe it directly over to the NetFlow collector. Also, the port-based QoS MIB is supported and provides some statistics for the low-end devices as well. Okay, what is it doing? Not sure what this is. Sorry, excuse me. Okay, so when we talk about NetFlow, so we went from the QoS MIB directly to NetFlow. NetFlow itself creates a flow record, previously created a flow record that was static. We had a list of items within that flow record. We weren't able to tailor the flow record, and some of that information may or may not have been interesting to us. So we went the way of flexible NetFlow just to provide the ability to create a flow record format so you could tailor to troubleshooting or tailor this specific flow record to what you want. We'll go over some of the details there, but source, destination, address are some of the fields that you can actually look at, port numbers and things of that nature. You can collect byte counts and things like that. All of that information can be directly piped via NetFlow version 9 directly to ManageEngine or Cisco Prime inside other applications like this, and be analyzed to evaluate the overall health of the network and allow us to modify our QoS policies. This also can be utilized by other monitoring features like performance agent and a big one, which is a PFR, and PFR can actually use the information to switch paths. We won't detail PFR since it's a routing thing, but essentially it's very interesting to see how it could possibly change the path of traffic based on that information. So how do we configure a NetFlow monitor? First of all, we have a flow record. We generate a flow record there in the second box detailing what you really want to classify, what do you want to capture. So your collect commands essentially are like bytes, counter, details, and things like that. Your match is based on your classification criteria within the individual flows. We're looking at the destination in this case and the source for V4 specific traffic. The exporter above that is where we're going to send it, so that would be the ManageEngine, a NetFlow collector, NetFlow analyzer. And then from there, we tie that into the flow monitor. From that piece, all we do is throw it on the interface. So we have the capability of having multiple flow monitors and analyzing, having multiple exporters as well. So what we could do is analyze traffic based on troubleshooting, focusing in on QoS attributes, or analyzing traffic, like in this case, we just want to look at source and destination traffic and see how much traffic is actually flowing through the box. So we can have multiple flow monitors and associate those flow monitors that are completely separate from each other to separate exporters as well. Now, one of the interesting pieces, and to me for QoS troubleshooting, NetFlow and NBAR integration are extremely important. So when we look at NetFlow as a troubleshooting tool for quality of service, we see it as really only determining applications by port or IP address. And it's layer 2 through 4 which it really exposes to us. When we look at NBAR, it allows us to do layer 3 through 7. So why not incorporate both of them, use the DPI to really look at the application itself, and then tie that to all the details from 2 through 4. And so we did that when we integrated NetFlow and NBAR. Now the way to configure it is just simply add match application name to your flow record, and then match class ID is another option that we have, so that your policy that's associated with the physical interface can be characterized inside of the flow data as well. So if you take a look to the right, we've applied this flow record to the physical interface. We see the source, destination IP address, the application name, the DSCP associated with that application, and even the class that that application is floating into. So imagine piping this out to ManageEngine and using that specific information to troubleshoot either the policy, verify that the policy is on the port, verify that the policy has the correct DSCP, verify the applications within the policy. The troubleshooting capabilities there are pretty much endless, and it's pretty amazing to think about because previously we didn't really have this visibility into the applications as we do today. The second piece of that is, instead of applying it to the port, you can apply it to the class itself. So within a class, we can look at the individual applications flowing through. We can determine the amount of bandwidth that the applications are requiring. We can look at the markings of those applications and all the details tied to that. So it gives us more ability to really look at the application, dive in and see, is this specific critical class getting the bandwidth and the buffering that it actually needs? Now, flexible NetFlow with NBAR 2 integration also adds on field extraction. So for those of you who have problems with HTTP, considering everything runs over HTTP these days, you can use FNF integrated with NBAR 2 to extract fields via NetFlow, via NBAR, extract those fields into FNF and export that to ManageEngine. So what you'll do is specify the match application name and then the HTTP host name and the URL. And if you remember the example that we went over previously, we looked at a specific server that was really critical to us from the browser traffic, and we took that out of the browser traffic and allocated a certain bandwidth to it. You could use this specific tool right here to determine which applications are important to you, which are business critical, and where are all of the users within the network actually traveling. So do we need to put some of this traffic in either scavenger class, or do we need to push this traffic directly into the business critical class, or do we need to take it out, as we did in the previous example, and say, here's an allocation of bandwidth for Google.com or Salesforce.com or something like that to provide us with more business critical needs associated with our QoS policy. From a CLI perspective, as beautiful as it is, you get to take a look at right here what we provide you from a CLI. So ManageEngine, the GUI is much better. If you pipe out the flexible NetFlow NBAR QoS stats, this is really good from a CLI perspective, and it's on a 3800 for troubleshooting basic problems. But when the problems get really difficult, you'll definitely want a NetFlow analyzer to look into quality of service. And the final slide, guys, IPv6 application monitoring. The NBAR and FNF integration for quality of service has come so far as to recognize that IPv6 is extremely important. We need to take IPv6 traffic into account also when we create our QoS policies. And we can take a look and do a deep dive into application monitoring by simply generating a flow record based on v6 source and destination and tying that to application name. So over here on the far right side, we can actually see the specific application name associated with it, the IPv6 flow. So that's one of the most amazing things from the IPv6 side. We're providing a lot more visibility into the applications, which makes QoS overall much easier to provision and to configure, because once you understand the bandwidth requirements and the buffering requirements of the applications in your specific network, you can develop a simple policy that will cater to those applications and simply distribute that specific policy throughout the network. All right, so thank you so much for letting me have the opportunity to speak to you guys about quality of service. I know it was fairly quick, and I know we had about an hour to really go over the details, and with quality of service we could spend weeks, sometimes months. So let me take a look over here at the question list and see if I can pull out some of these questions. Into the chat window here. Hey, Don, were there actually any questions that we need to go over?
Yeah, so we have had a bunch number of questions during the webinar, and for that, thank you so much for a great presentation on quality of service. So I'm sure, like you said, yeah, people would actually be glad to listen for another hour or even on months if they have to learn about QoS, know more about QoS. So I'm actually assigned, I've actually just passed on a couple of questions, and yeah, users can also start posting in your questions. And while you type in your questions, I'll just show you some of the screenshots from ManageEngine on how some of the QoS reporting looks like. So we can have a look at the reports from ManageEngine NetFlow Analyzer on the QoS reports. I'll just share my screen, and meanwhile users can start sending in their questions. We'll take a couple of questions and discuss them. Right, so QoS reports using ManageEngine. All right, so two ways to get QoS report. One is by querying the Cisco class-based QoS MIB, where we send out SNMP queries and we get reports on each of the policy, child policy or classes, and as well as give you pre and post policy statistics, volume information when there is a drop in traffic, drop information based on volume, speed, and utilization. And then there is match statement report for each classes. You might use match statements to identify a traffic group and assign them to a policy. So match statement statistics for each class, and you can even view the configuration of your policies from the NetFlow Analyzer UI. So this is a report where NetFlow Analyzer automatically identifies the policies applied on your router, and you can see reports, like I said, pre and post policy traffic statistics. What is the drop? What is the queuing? And how much percentage of traffic was dropped under each traffic, each class, each policy. And you can see reports for the parent policy as well as the child policy and class-wise reports also. So that is how detailed the reporting is. And you can view the configuration. That is something else where you can make a note of your configuration when you see the report there, and you can drill down to a class. A traffic class is this traffic group and where you can drill down and see what is the pre and post policy traffic statistics for each class. And from there, the other option is NetFlow based reporting to see how your DHCP priority. So NetFlow report, NetFlow is a feature that's available in almost all Cisco routers from 800 series onwards. So you can use NetFlow, the latest version, the flexible NetFlow, NetFlow V9, so to see your traffic report. And in that NetFlow, you get differentiated services code point or diffserv information, and you can see the markings for each conversation. You can see what is the priority, CS1 or default priority, or whatever priority you have assigned for each conversation. You can see the priority. You can also see the groups, DHCP groups available, what are the set of applications running under it, and you can further drill down on the group to see the report for what are the conversations under each of the DHCP classes. I've just marked out some of the IP addresses because we are using this for our live setup here. So that is how useful QoS policies is. So using QoS in your network is to get priority for the right applications and stuff like that. So questions, we'll take them one by one. Let's see, we're getting a lot of questions now. Great. So
I can, I mean, Don, if you're done, I can go ahead and take a couple of those. I'm looking at them in the window.
Definitely, I'll just pass out a few questions to you.
That's fine. I can actually, I can read them. I see them right here. So okay. The first one is, so what is the best process when implementing QoS and trying to discern between traffic, web traffic when some is internally hosted? So with NBAR on the WAN edge, you do have that capability that browser-based traffic and HTTP-based traffic, even though it's internally or externally hosted, you can specify which specific server. So there was a quick slide on that. I don't know when this came in, but if that specific slide, if it doesn't answer your question, again, I'll try to expand on that a little bit more if you want to send Don an email. But the idea is to look at the HTTP traffic associated internally, look at that specific server, and tie that specific server to a subclass or a child policy internal to the main policy where you specify all, for instance, browser traffic. So what you can do is, if you have a single type of traffic like that example of the browser, the subclass can actually be called out based on the server. And you should be able to do that with most things internal to NBAR and NBAR2 based on the number of signatures there. So you may have to specify the IP address of the server, unfortunately, in some cases. But the idea here is to look for either the URL or the IP address of that specific server to pull it out from the overall policy within the best effort class. And again, if that doesn't answer the question fully, then please feel free to send Don an email or myself, and we'll get back to you on that. The second one, how to identify streaming audio and put it into Scavenger. So depending, again, you can look at the specific streaming. There's a streaming application set inside of NBAR 2 that will provide that. You should be able to do a match based on the streaming audio. I see what you're saying from the perspective of there are overlapping port numbers and things of that nature for voice and video, and so it's very difficult to classify the traffic. But NBAR 2 does have a streaming audio piece. You should be able to verify streaming audio with NBAR 2 and pull it directly out of the best effort queue. That is one of the easiest ways to the scavenger queue, which is what you want to do. So the next question is, will NBAR actually match based on URL when a proxy is used? I'd need a little bit more information, but to be honest with you, I don't believe there'll be an issue there. So when you use the proxy, if the same URL instance is actually internal to the application flow, you should definitely be able to match it. If you aren't able to match, sorry, it just moved. If you aren't able to match based on that URL, there should be a way to create an NBAR PDLM and NBAR signature to focus in on that specific application that you're really trying to look at. And again, you can please do send me more information on that guy, because I think I'd have to have a discussion on that one. Can I use Prime only for? So you're asking about Cisco Prime. The question, sorry, is can I use Cisco Prime only for Cisco devices? The answer is Cisco Prime is actually a huge entity, and we could have a whole conversation on that. The fact is that there's a NetFlow analyzer and all sorts of other individual pieces in there for Cisco Prime that will actually take care of third-party things. So yes and no. Cisco Prime is a full-on entity that can be used for third-party as well. But that would have to be a conversation, again, that we could talk about Cisco Prime all day. So I apologize. I don't have a succinct answer for that one.
Oh, we seem to be getting quite a lot of questions here. I think maybe
Do you want, because I have, there are quite a few, so do you want to take some of these offline and directly email the participants? Or?
Maybe we could email these questions, yeah, take the questions offline and email them directly to the participants, because we have a lot of questions coming in actually.
I do see that. Okay. Well, Don, thank you so much for your time. I do appreciate it. I'd be more than happy to entertain the questions. And guys, feel free. I guess you have Don's email. Feel free to send an email based on this, and I'll definitely answer the questions as soon as I get them.
Yeah, Ken, thank you so much for joining us today and for such a great presentation on QoS, quality of service. And for all the participants, you can email your questions to us, and we'll actually reply to you, and the recording of the webinar and the presentation will make them available within a week, and we'll email that also to you. So thank you, everybody. Thank you so much for joining the quality of service webinar from Cisco, and have a great day.